So I'm going to go through an overview of the group project here. So on this first slide, I have a brief overview of everything, and we'll go into detail for each of these sections as we continue on with this presentation. So what you're going to do is you're going to break into groups of 4 or 5 students. So from there, what you're going to do is you're going to answer a quiz. There'll be a quiz posted on Blackboard asking you to name what your team is and all your team members, and you'll submit that through Blackboard. From there, as a team, what you're going to do next is you're going to pick a practical problem similar to something you've done throughout the semester. Now, this is a problem that you're going to create on your own. It may be similar to something you've seen in the book, lectures, an exam problem, but you're going to create your own problem. Don't just copy one from the book. I want you to use those as inspiration and give you ideas for problems that you're going to create. From there, what you're going to do when you create your problem is make sure that you have an illustrating diagram and write out a problem statement that tells what's going on in the problem and provides all the necessary information. If there's going to be assumptions you want them to make, it gives them the information to make those assumptions in order to solve this problem. Now from there, what you're going to do is go ahead and solve out your own problem. So you're going to solve the problem, and I want you to follow these steps along the way. Make sure that everything is clearly labeled and you describe what you're doing in each step of your solution. Keep everything neat and organized throughout the solution so somebody else can follow through your work. Show all your general equations. Say where those came from within the textbook. Explain your thought process for each step along the way as you're solving your problem out. Then from there, make sure you clearly define and label the chosen coordinate system and why you chose that coordinate system. If necessary, draw out any of your free body diagrams and use correct units. Now, there's 2 reasons I want you to do this. 1, I'm going to be grading your problem and your solution to your problem. 2, you're going to be handing your problem out to the other groups within the class. Those other groups are going to be solving your problem and turning them back into your group for you to grade their solutions to your problem. So you're going to want this nice and organized so you're grading out the other group's solution to your problem. You can go through and clearly follow that 10-point criteria that we'll talk about down here so that you can give them a graded solution, thoroughly graded from each of those sections right here, handed back to them. So this project is going to be graded and count towards your group project part of the presentation of the grade. So I'll give you the breakdown of how the percentages of each portion of the project are going to contribute to that final weight of the grade. Now there's a couple deliverables that you're going to have throughout the semester. 1, you're going to hand your problem and your solution into me. So that's going to be a portion of your grade. That's one of the deliverables right there, is your problem and your solution to the problem. Second, you're going to be grading the other group's solutions to your problem according to a 10-point scale. So that's going to count towards your grade. That's the other deliverable there, is actually solving the other group's problems. Last, your group is going to present your problem and your solution on Teams the last week of classes. So that'll be the last portion and the biggest portion of your problem is your presentation of that problem to everybody else in the class and your solution to that as well. So again, these will all be graded on the same grading scale that I grade your homeworks, the TA grades your homeworks and exams. 2 points for your format, 2 points for neatness is easy to follow, 4 points for the correct method in solving the approach, and finally 2 points for the final correct answer. So now let's break these down. The first step in this group project is you guys are going to need to break into teams. So as you break into teams, this will be a quiz I'm going to post on Blackboard, and you'll need to complete the following right here. Well, you'll write out, okay, we've chosen 4 to 5 students to be within our group. This is our team name. These are all the members within the group here. So this will be something that you'll submit as a quiz through Blackboard for your team. And I want you to get started on this early so you guys have an opportunity to start chatting, talking together as you're going through your homeworks, as you're going through the exams and sample problems and lectures. You'll get an idea of the type of problem you want to create for this class. Second, what you're going to do is actually create out your problem. So again, similar to something you've seen within the textbook, lectures, exams, example problems, any of those things, but don't exactly copy it. Make up your own. Don't just copy one from the book. Again, you're going to want your illustrating diagram and your problem statement to tell exactly what's going on in order to solve the problem right there. So you can see I have a diagram over here on the left. There's my illustration for part A, and for part B, now I have this problem statement over here that you can see there where I say, okay, ball A is released from a height of 40 feet. At the same time that ball B is thrown upward 5 feet from the ground. The balls pass one another at a height of 20 feet. And I ask you to find the speed at which ball B is thrown upward. So between the problem statement and the information that we can see over here in the diagram, we can understand clearly what's going on, and we have all the information we need, and we can provide this to the other groups to solve in order for them to actually solve this problem out. So again, make sure between the diagram and your problem statement, you've given them enough information to actually solve the problem out. And that's why you going through with your teammates, double checking each other and solving it out, make sure you're not making any assumptions that other groups aren't going to be able to make within it there, and everything is clearly labeled and clearly worded within your problem statement and initial diagram. Now from there, you go on to step 3. So again, go through and solve your problem. Follow all these steps we discussed before. Clearly label what you're doing along the way. Everything's neat and organized. Show your general equations, where those general equations came from. Explain your thought process. Write it out right next to it of what you did and how you did it for each step in the solution. Clearly define and label your coordinate system, and even state why you chose to go with that coordinate system there. If necessary, any free body diagrams drawing out for each individual part and member within it, and make sure you use the correct units and do unit analysis along the way. So this is for your solution to your own problem, and also for your solution to the other group's problems. Follow this step as well. So then from there, we do that here. So this is our solution to that problem that we created as a team. So I clearly say, okay, these are my givens, just like my setup page right there. I've clearly labeled out everything that's given in the problem statement. I've clearly labeled out what they've asked me to solve for in this. I have my diagram. Right there's that chosen coordinate system, clearly labeled X and Y, what direction is positive within that there. I've redrawn out my diagram right there. So I have my setup page created for that. Then I go on to begin the solution there. So we now go on to finish our solution. We can see, okay, first we're considering ball A. So I've clearly labeled, I'm looking at just ball A here. I have an associated governing equation for ball A or a known value for ball A. Anything I have for information from that in my problem statement, I've clearly labeled this as just for ball A there. I still state here, okay, ball A starts from rest. So this is what I can infer from starting from rest right there. My initial velocity, my initial position. And then I recall the kinematic relations for constant relationship. So this is telling me what governing equation I'm going to be utilizing for this. Then I'm clearly stating what I'm doing next. I'm taking that governing equation, I'm plugging in my known values, and I take out the extra steps all the way along the way. And where this is important to do out these extra steps is maybe if the other student who solved yours, the other groups who solved yours, just went from our governing equation down to our final answer of t, and it was wrong. Maybe it was off by a factor of 2 or after a factor of 10. If they've shown their work and you've shown your work, you can figure out where they've gone wrong with that. And you might cut off, oh, that's just a carry through error. I'm just going to take off half a point here. Or, wow, they used the wrong governing equation, or they plugged in the wrong value. Therefore, I need to take off X amount of points. So then we continue on and we clearly label here, oh, now I'm talking about ball B separately right here. Okay, here's all the information I have here. Okay, now I'm talking about when ball B reaches 20 feet at the same time as ball A. So I'm saying why I can equate these two equations there through time like that. Then I go through with my governing equation again right here. So I've clearly pulled out my governing equation. You could even say where this came from in the book or what relationship that is there. And then now you can come down here and go step by step as I plug things in. And again, I have my units here so I can double check my unit analysis all the way to the bottom and check that it came out right in the end for my units for what I'm actually solving for. So this is the format that I'm expecting you to follow for your solution to your problem and to the other group's problems. And especially as you're presenting this at the end of the semester for your problem and your solution to your problem, as you guys take turns, you can divide up the task however you want within your teammates. Maybe one person talks about the given page. Maybe one person talks about how you created the problem. One person goes through your governing equations. One person talks about where you plug in or how you did some certain calculus within it. One person talks about the free body diagram. Things like that you can break up between members of your group as you present at the end of the semester. So milestones to consider as we're going through our group project right here. So Tuesday, March 2nd, this week right here, this quiz this week is going to involve you forming your teams, just like we talked about in that format there. And these are also labeled on Blackboard as well through that quiz assignment right there. So you'll be able to follow that template, plug in your team name and each of the members' names within of your team as well. So that's going to be that week of March 2nd. Then on Thursday, April 22nd, you're going to need to submit your group problems with your solution. And this will be an assignment on Blackboard during that week. So you'll submit those on Blackboard on April 22nd. Then on April 29th, you're going to submit your group's solutions to other problems. So on April 22nd, when you submit yours through Blackboard, they will be redistributed to all the other members in the group. So you'll have 1 week to complete the solutions to the other group's problems and hand them back into that group via Blackboard. On the 29th, I will get those from Blackboard to the appropriate team members, and you will then grade those solutions right there, which your grades will need to be completed and turned in by the last week of classes, May 4th through May 6th right there, when you also are doing your virtual presentation on Teams and then turning in those graded assignments back to the other groups as well for their solutions to your problem. So those are the main timelines that we need to keep track of right there for the group project for this semester. Now for your evaluation criteria, how this breakdown will go. So your problem, your solution that you hand in me, then I'll count 25% of your grade. So as long as you've completed that in the correct format, followed all those steps with everything I want to see within your solution is correct, that's 25% of your grade right there. Then you'll be graded on 25% will be the grade that you get for all the other problems in the class. So let's just say there's 5 other groups problems that you solve out. 25% of your grade will be the average of all of those right there. That'll be graded by those individual groups. And then the bulk of your grade, 50% of your grade, will be from the presentation. How clearly do you explain it and go through your solution right there. So as long as you've actually done the problem out, done well in this first part here, and solved out correctly and create a good presentation, this should be easy to get the bulk of this points right here from that 50%, as long, again, assuming that you've taken the time. So again, this is why I'm starting this early in the semester, is I want you guys to get together as your group, form the groups this coming week, make sure you have a good problem. Feel free to contact me if you have an idea for a problem, like, hey, would this be good? Or, hey, is my solution right along the way? You don't have to go into this completely blind. Feel free to utilize office hours, come in and ask questions that you may have about the problem that you're creating. That way you can be sure that when you get to the end of the semester and you're presenting it and you're grading other students' solutions to your problem, you have your correct solution as well for a good problem with all the necessary information provided for the other groups to solve it. So grading, this breaks down again to that same grading criteria that we've used for all your homeworks and your exams for the semester right here. So you're going to award 2 points for neatness. Did the other groups have a nice, neat format right there, easy for you to follow? Did they have the givens? Did they have the finds? Did they have the correct coordinate system? Did they have everything labeled? So that's 2 points there. Is it neat and easy for you to follow? Could you go through their work and look at it, or was it a jumble all over the place and it was hard for you to find and determine what they're doing? Did they use the correct method and approach to solve your problem? Now, one thing to consider here, as you're making your own problems, your own solutions, there may be more than one method to solve it. So just because somebody used a different method than yours, it still may be correct. They may have chose to solve for member AB instead of member BC, but that's still okay because they equated it back in the end as the whole system and got the right answer. So make sure as you're grading a solution, you realize that your method and your approach may not be the only one. So as you're doing your solution, maybe think of alternate ways for you to solve that. And you can even include those in your presentation as well. And last, for the last 2 points, did they get the correct final answer to your problem?